We're going to look at the last section of chapter 10, which is going to be the abuse of statistics. So we want to start opening our students' eyes to not every number presented is going to be accurate. Abuses of statistics. A lot of people talk about statistics lie. So this is going to be sort of what this lesson is about. People sometimes deliberately mislead people with statistics, and this is often seen in advertising. But usually it's misinterpreting the data, and it's not necessarily an intentional misleading, except for in advertising, that's probably the case. So let's consider an advertisement that reports people responding to a survey, 98% said this medication is the best thing I've ever had. So to certify that statistics are not being misused, I have questions, right? I want to know, well, what did you ask them in the survey? How many people did you survey? Because if you surveyed 2 people, we have a problem. And then how many people responded to the survey? Maybe they only heard from 10% of the people they sent it out to. I need to know these things before I can make a valid conclusion. Also, how were they chosen? Were they actually taking the medicine as compared to not taking it? Well, and then how many types of painkillers have they tried? Have they tried Advil, Tylenol? I need more information than that. How were their answers interpreted? Were they a scale of 1 to 5? Was it a yes, no? Without all of that information, I really don't know a whole lot about this 98% figure. There's a lot more questions than that number provides me with. Here's another one. This time, I only had 50 people respond out of a million. So is anything from that valid? If I look at of the 50 people responding, let's say 49 were yes. So that 98% claim is true, but 999,950 didn't respond. So why didn't they respond? Maybe they don't like the painkiller. So there's some fishiness. What if this one says it's the best pain reliever I've tried for headaches and arthritis? Well, did they ask about other pain relievers? Did they ask specifically about headaches and arthritis, or did they just ask in general? What if the people who received the survey were from a town where they manufacture this and a lot of people are employed by this plant? They might answer differently because of that. What about if they only compared 2? What if they just said Tylenol versus this? Or what if they gave them a sugar pill and they said, how does this work compared to this? And the people didn't know they were taking the sugar pill. That could also be a problem. A different type of misuse would involve graphs. Sometimes I can choose ways to represent data in numbers in ways that are misleading. If a graph doesn't have a good title, it's a problem. If the labels are not clear, it's a problem. If I don't know the source of the data, that's a problem. I need a key if I have a pictograph. I also need uniform size of symbols. It has to be the same symbol and all throughout the representation. Well, I also need the scale. Does it start at 0? Does it start at a negative value? That needs to be clear. Are the numbers evenly spaced? So am I going every 5 or every 10, or does it suddenly change from 5 to 10? So when I look at these abuses, a line graph, a histogram, and a bar graph can be really altered by changing that scale. Like, look at the difference here. I started at 0 on the left. I started at, I don't know, 40 on the right. Well, all of a sudden, that looks better to me, right? So I'm shifting the things around. Same thing here. Well, if I suddenly compress those numbers on that horizontal axis and I make them really tight, look at the difference here. So there's a huge drop off, but it suddenly doesn't appear to be a huge drop off. It appears to kind of nicely slope down. Here's another one. Here's another example of an error that frequently occurs is I'm looking at data that's supposed to be discrete, but what's happening here with this line graph? What is this line telling me? Is it telling me anything? I don't know. Many points along that line are just meaningless. I don't know what they are. Another way would be to omit a scale. I just don't put it. Look at the left and look at the right. I didn't put a scale. I don't know what's happening on the left. Here's another example. I made one box really big because it had a really big scale, but now Sugar Pops is this tiny little thing. Again, that affects things. Well, what about this pie chart? So pie charts are really easily distorted when you try to make it 3-dimensional. All of a sudden, 27% just looks huge. And it's really hard to see it in reference to 12%. It looks way bigger than 12% because it's in three dimensions. So the final examples of the misuses involve misleading examples of mean, median, and mode. These are all averages, but they can be used to suit a person's purposes. And the main thing to watch for is that when a mean is reported, the reference group can't have outliers. We can't have random values. If the sample is small, then just a few values are really going to throw off the mean. And that's what you need to watch out for when you're looking at mean, median, and mode.